e-commerce platform where the checkout experience had a tight window. The moment a user clicks on Place Order, a confirmation modal pops up, showing details like a unique order ID, the timestamp, and the user's name. But here's the twist. The modal disappears in just 5 seconds as it redirects to the payment gateway. Now, to handle this automation-wise, the key was timing and responsiveness. What I did was build the script in a way that the moment the Place Order button is clicked, my automation instantly starts watching for the modal. It's like standing by the door, knowing a guest is about to arrive, and you're ready to open it the second they knock. Once the modal appears, instead of trying to match exact values, which can be tricky due to the dynamic nature, I focused on checking that the order ID was present, and in the expected format, the timestamp was not blank, and the username matched the current session. To avoid losing that moment, where the modal might flash and vanish, I used a clever trick. I set the script to actively wait until the modal becomes invisible, and during that short visible window, it extracts everything it needs. It's like taking a snapshot before the moment slips away. This helped me avoid flaky failures due to the redirect. I also made sure to grab a screenshot as soon as the modal popped up. This not only helped in validations but also became a handy artifact during reporting. To summarize, I combined quick detection, targeted field validation, and safe exit strategies to make sure we caught everything we needed from that fleeting modal.
Let me share a situation I faced in one of my projects. We had a React-based analytics dashboard where each widget was like a small app of its own: weather data, user stats, transaction history, and more. The tricky part, they didn't all load together. Some popped in instantly, some took 2 to 3 seconds, and others, well, they behaved like a slow coffee machine on a Monday morning. Initially, our Selenium scripts were failing because they expected all widgets to load at once. If a single widget didn't load quickly, the whole test case went red, even though the widget wasn't business critical. This was wasting time in triage. So, here's what I did. I redefined our test approach to classify widgets into 2 groups, critical and non-critical. For critical widgets, we used explicit waits to ensure they were ready before checking the data. For non-critical widgets, I introduced a retry mechanism with a tolerance, meaning if they didn't load on the first attempt, we'd try again after a short pause, but we wouldn't fail the whole test if they still didn't load. This approach mimicked a real user's patience. A real user wouldn't abandon the dashboard just because the stock tips widget was slow. They'd check back in a moment. By separating these behaviors and making the framework retry smartly, our test flakiness dropped by more than half.